Welcome back to this Python tutorial series on constructing a recursive descent parser for a calculator language. And in today's video, we're going to be introducing exponentiation. And so, just as a fresh reminder, exponentiation simply refers to the fact that, let's say, we were to say 3 raised to the third power. We need a way of representing 3 raised to the third power. We're going to do that by use of the caret symbol. This is going to say 3 raised to the third power, which simply means we're going to take 3, our base, times it by itself 3 times. So this would be 3 times 3 times 3. And in order of precedence, powers must be calculated before anything else. So if we were to say 3 minus 3 raised to the third, raised to the second power, this needs to evaluate before subtracting 3 minus this value. And in addition, in multiplication, this value needs to be evaluated first before the multiplication. So now we have to introduce another level of precedence into our grammar. And from the very beginning of the video, of the previous videos, this was our original grammar here, which only handled addition and subtraction. And then here, now we have this was our other grammar that we introduced for addition, subtraction, multiplication, and division. And now, if you can tell, we added some temporary productions known as T1 and T2. And so what you can do here is you can actually pause the video and try to actually come up with a grammar and alter our current grammar, as we can see here, which supports parentheses and negation, and try to see if you can add another production, maybe call it T3, and include Operand 3, and try to see if you can even come up with such a grammar. So I'm going to let you pause the video now. Okay, you've either paused the video or you skip right through it. So here's the actual grammar. This is the given grammar. Here we have another level of precedence. We introduced the variable T3, and we introduced factor. Actually, factor was present before. All we did was introduce T3 and another production called temp. So this way, temporary is going to be called on term instead of factor being called on term. And so here is going to be a quick derivation. Of the example, 3 plus 5, take that whole expression and raise it to the 7th power. So here we actually have the syntax tree, the derivation tree. And what we can do is we can take our statement, divide it into term T1, where term is a temp T2, and temp is a factor, factor 3, and then a factor is a final, and then a final is an LPAR statement, RPAR. And we can continue the cycle all the way down. And now, since we're pretty far into the tutorial, so I'm assuming you guys know how to actually derive this, so I'm not going to go through the labor. But as we can see here, we're adding lots of layers to our grammar. And in the previous tutorials, I've actually just shown you how to fix these grammars. But what you can do now is, because you have previous experience of fixing the grammars through the tutorial, you can actually pause the video now and see if you can implement this new grammar into our previous parser. So you can pause the video now, come back, and I'll show you how to do it. Alright, so now I've either assumed that you've tried and failed, or tried and succeeded, or haven't even tried at all. So let's actually take this grammar and implement this now. So we're going to take this, go here down to the very bottom, begin with start. Well, start is the same. Start is still a statement, okay? Statement is still the same. Statement's still a term T1. So now let's go on to term. Term is no longer a factor T3. Term is no longer a factor T2. It is a temp T2. So we're going to make a new function. We're going to call it temp of myIter. We're going to pass in the iteration. So what is, we're going to change this to temp. What we can actually do here is copy and paste this here. because it is the exact same, except the only difference is we're calling T3 here. So here we have temp. Temp is a factor, T3, whereas term is simply a temp T2. All right, so now we have to implement T3 and T2. Excuse me, T3, and we have to implement, I think that's it actually, just T3 and operand 3. So we're going to say T3 of my iter, and what we can actually do is just copy and paste here, let's say from T2. Because it's going to be the exact same structure. We're going to give it a previous value. This is going to be an operand 3, as we can see. T3 is an operand 3. It's going to call factor. Operand 3. We're going to call T3 again. Everything still stays the same. Now we need to adjust T2. So T2 is operand 2 temp T2. So it is T2 operand 2, not factor, but now temp. T1 should stay the same. It's an operand 1 term T1. Operand 1 term T1. We fixed up T2. Now we've done T3. And the last thing we need to do is implement operand 3. So we're going to give it a left, an operand, and then a right. And so now what we're going to do is we're just going to say, we're going to say right.value is equal to the left.value, the float, float.value raised to the float of the right.value. We're going to say if operand equals exponent. This way we can actually include more operands of the same precedence. So here we have our derivation tree. This is just going to be a nice little example of how we would derive this. So here we have operand 3. And the last thing we need to do is include the operand 3 in our scanner. So we're going to go back up here. Just going to copy and paste this. Operand 3. It's going to be the caret symbol. And so now this should be working. So let's test it out. Let's say 3 raised to the 3rd power is 27. Very good. Now let's do our example. So 3 plus 5 raised to the 7th power. So that's 8 raised to the 7th power. So let's say 8 times 1, 2, 3, 4, 5, 6, 7. So we can see it worked. So now our calculator can support addition, subtraction, multiplication, and division with negation, parentheses, and now exponentiation. So hopefully you guys have learned about grammars, finite automatons, and how to implement finite automatons into scanners, and take your grammars and construct a recursive parsing algorithm for them. And this is a very powerful tool for calculators, and you could probably even use this in a resume project, because it's a very neat thing as it shows that you're capable of implementing recursive algorithms. So hopefully you've learned something from this, and in the next video I'm going to show you guys how to implement variables into our calculator. So stay tuned.